Okay, we're back for problem number 5. We have two numbers are opposites of each other if their sum is 0. Which are the opposites of the following numbers? So we have positive 8. Well, its opposite would be negative 8. We have negative 3. Its opposite would be positive 3. We have 1. Its opposite would be negative 1. We have negative 15. The opposite would be positive 15. But now, as we do in algebra, we enter into the variable zone, and we have x, positive x. So what would be the opposite of positive x? Well, it would be negative x. And we have negative y. Well, the opposite would be positive y. So you can do opposites, and remember, variables represent an unknown number. But here's where we can start talking and saying, well, why is it that when you add x and positive or negative x together, you say that's 0 because you're saying, for instance, we were saying 5. I'm sorry, let me just take the first example. It would be 8. And we're saying that negative 8 and that their sum is equal to 0. Okay, this is where we're going to have to understand that when we say x has a value in an equation or in a sum, an expression, we're saying that that value x will always be x wherever it's found within that equation. So we're saying that these two are equal to 0 because whatever you tell me x is here, it's going to be the same number there because it's being represented by the letter x. So if I ask you right now, give me a number for x, and you say 5. Okay, so we have to put 5 in for x, and then I have to put 5 in over here for negative x because they're the same. Okay, so now we have 5 plus negative 5. And no matter what number we choose, whatever number we choose to put in for x here, it's going to be the same number over here, except it's going to be a negative. So regardless of what we choose, even though we don't have the number, we can always say with certainty that whatever x is, adding negative x to it will be equal to 0 because x will always be the same number. In this case, we used 5. If you told me 15, I would say 15 plus negative 15. But you might say, well, why don't we change this x to be another number? Well, you can't because it's x. It's the same. Okay? Had we had a different variable, and I can tell you, let's say x plus negative y is equal to 0. Now I can't say that. I cannot say that with certainty. It could possibly be that it equals 0 only if and when x and y are actually the same. But because we're using the letter y, okay, we're saying that y can be anything that x isn't. In other words, it could be, let's say, 5 here, but y could be whatever number that x isn't, because we're not saying, because we know that x and y are not the same, right? They're two different letters. And though we could somehow say, well, I want y to be the same number, that's okay, but it's not assumed because it's not in the expression. Okay? And then the question would be, well, why did we use y if it was the same? We should have just used x, shouldn't we? Right? So it should have been written, much better written, x plus negative x. In other words, if x was going to be the same. So this is a little bit more insight as to when we use variables, why we can add and subtract variables and change their values, so to speak, without really even knowing what their true value is. Because we can handle that variable almost as if it were a number. And we'll do a little more of this later on when we show you how to multiply and divide variables. But this is just a little bit more as to why x plus negative x is equal to 0.